Okay, guys, in this example, we're going to look at computing the limit of a function of two variables. And this is a limit that most likely will not exist, but we're going to have to prove why that's the case. We got 6xy plus y cubed divided by 7x squared plus 9y squared. Okay, the first thing we do is look at what happens to this function as you are moving towards 0, 0, but you have to stay on the x-axis. So x-axis is the equation y equals 0. So we are going to plug in y equals 0 into the expression, but keep x the way it is. So x is still going to approach 0, but y will be changed to 0. Okay, so let's just substitute everywhere where we see y, we substitute 0. Now we want to compute what we got. Now on the top, notice that we are just going to get 0. And on the bottom, this is going to simplify to 7x squared because the other term is 0. Here you got two options. If you try to substitute 0 into the bottom, you will see that this is 0 over 0, which is actually what's called an indeterminate form. This does not mean the limit is undefined, and also it does not mean that the limit is necessarily 0. It just depends on the situation. So there are two ways you can do it. You can formally prove it by using L'Hopital's rule. L'Hopital's rule says that you can just take the derivative both of the top and of the bottom until you get something that's not 0 over 0. Okay, so if I take the derivative once of the top and of the bottom, it's still 0 over 0, but one more derivative is going to give me 0 over 14, which is equal to 0. So at that point, it's now no longer 0 over 0, and that is 0. So I already know that this part is going to be 0 right here. Now, there is another argument you can make, and that is if you look at this expression, this is 0 divided by something. But when it says that x approaches 0, it could get very close to 0, but it's never going to be actually equal to 0. So imagine that x is like 0.0001. It's still some number that is not 0. And 0 divided by any non-zero number, which is not 0, is just going to be 0. And so you don't even need the L'Hopital's. It's kind of an overkill. But anyway, it's fine if you want to use L'Hopital's just to make you feel better. Okay, x equals 0 is the y-axis. So now you're going down towards the origin by going from the y-axis. Okay, so this time I'm going to substitute y. No, y will go to 0, but x will be 0. Okay, so let's substitute x equals 0 and keep y the same and see what happens. So looks like on the top, I'm going to get y cubed. And on the bottom, I get 9y squared, and y approaches 0. Now, at this point, if you try to substitute y equals 0, you'll get that 0 over 0. So you could use L'Hopital's, but you can actually first reduce it, right, by using rules of the power. So when you got y cubed divided by y squared, that's just y. So you get y divided by 9, which is no longer 0 divided by 0. When you substitute 0, this is just going to become 0 over 9, which is 0. And so that's 0. Now, a lot of times I see students saying, well, both of these answers are zeros, so that must mean that the limit is also going to be 0. I just proved it. That's not true. When you are approaching 0, 0, which is your origin, you can approach it from the x-axis like this, from this way. You can approach it from the y-axis this way, but you can also approach it in million other paths that lead to 0, 0. So if you're really thinking that it's going to be the same, then you have to check all possible paths that can get to 0. Okay, it's a proof that you have to do. Just because two of them are the same does not mean anything at all. Okay, so far we didn't find a contradiction, and it's useless. Okay, let's see what happens next. Now they're saying, okay, why don't you try the path y equals 2x? So it's going to be, something like this. that we approach 0, 0 from that path. Okay, so for y equals to x, let's substitute that into our problem. And x is still going to approach 0, but y becomes 2x. So let's see what happens. Now be careful, cube the whole thing. Divided by 7x squared plus 9. Instead of y, we put 2x and square that. Okay, so a lot of algebra here before we can get our answer. So this simplifies to 12x squared. This simplifies to 8x cubed. At the bottom is 7x squared plus, well, this is 4, and times 9 is 36x squared. Okay, so notice that, of course, it is going to be 0 over 0, but you can actually factor out x squared from the top. And that becomes 12 plus 8x. And on the bottom, you can also factor out x squared, and that's 7 plus 36, which is 43. And now we can see that these are going to cancel, and we're no longer going to have 0 over 0. So now when we plug in x equals 0, that just becomes 12 divided by 43. And I think that's the answer here. Let's check that out. Okay, now we did get a contradiction. So even though the answers along the x-axis and the y-axis were the same, but we did find another path which did not give us 0, which means that the limit cannot possibly exist, because if it did, all of our answers from all possible various paths would have to be the same, but it's not. So that just means that the limit doesn't exist.